Welcome to doassignment-ca. Here is the problem. A 3,500-pound car has its speed plotted over a 30-second time period. From the velocity time graph, for the interval from 0 to 10 seconds, the speed increases linearly from 0 to 60 feet per second, and for the interval from 10 seconds to 30 seconds, the speed increases linearly from 60 to 80 feet per second. Determine and plot the variation of the traction force F needed to cause the motion, assuming a horizontal road with no friction or aerodynamic drag. Now let's work through the solution step by step. First, we find the mass of the car. The weight is 3,500 pounds. Dividing by g, which equals 32.2 feet per second squared, gives a mass of about 108.7 slugs. All force calculations will use this mass. During the first interval, from 0 to 10 seconds, the velocity rises linearly from 0 to 60 feet per second. The acceleration is the slope of that segment, 60 minus 0 divided by 10 minus 0, which equals 6 feet per second squared. Applying Newton's second law, force equals mass times acceleration, we multiply 108.7 slugs by 6 feet per second squared to get a constant traction force of 652 pounds during the first 10 seconds. In the second interval, from 10 to 30 seconds, the velocity increases from 60 to 80 feet per second over 20 seconds. The slope, and therefore the acceleration, is 20 divided by 20, which equals 1 foot per second squared. Applying Newton's second law with the new acceleration of 1 foot per second squared, the traction force drops to approximately 109 pounds and remains constant throughout the second interval. Combining both results, the traction force equals 652 pounds for the first 10 seconds, then drops abruptly to about 109 pounds and remains there for the final 20 seconds. Because acceleration is constant within each interval, the force-time graph consists of two horizontal steps connected by a vertical drop at 10 seconds. As a final check, multiplying mass times acceleration in each interval reproduces the forces we calculated, 652 pounds and 109 pounds respectively. The units work out correctly because slugs times feet per second squared equals pounds. Both answers are verified. Visit doassignment.ca for more study tools, AI learning support, and online tutoring.